So obviously this meeting is going to be in the context of web development. What we're going to do is go over a couple of problems that I kind of stole from Edibit. One of them I kind of made up on my own, but mostly stolen from Edibit. And if you haven't heard of Edibit, it's a really awesome site. I'm going to share my screen. It's edibit.com. Yeah. And they've got a bunch of awesome problems and puzzles. I would say that if you're just learning how to code, you really can't do enough of these. I pretty much can attest that my fluency as a software engineer is mostly because of stuff like this. They're fun, they're challenging, and and doing these kinds of puzzles will help you become fluent in JavaScript. I mean, it really will, because it forces you to use parts of the language that you've maybe never tried before. It's just a really great way to kind of nail down the syntax to the point where when you look at code, it doesn't look like Russian hieroglyphics. It looks like, the language you already know. If you already know Russian hieroglyphics, which I don't even think is a thing. But if you know that, then maybe you'd be good at coding. I don't know. I just made that up. Okay, so first thing we're gonna do, well, actually, does anybody have any questions before we get started? Feel free to pipe up. Cool. And I'm sharing my screen, so the chat is a little bit hard to see. So speaking is a little bit easier, just FYI. All right, cool. So I'm just got VS Code over here. So just to start is I'm just gonna go over some things that I've found to be really useful or when I'm tasked with something that I've never done before, never used before, I kind of have a checklist that I go through. And we're gonna try to apply this checklist to some demo problems here in a minute. I just wanna kind of go over in general, kind of the steps that I take. So the first thing, which seems really obvious and self-explanatory, but it's understand the problem. And that means being able to summarize it as succinctly as possible. And this is the most important step, because if you don't even understand the problem, or if you misunderstand it, if there's something you're either taking for granted or making assumptions about that aren't correct, then no matter what you do afterwards, you're not gonna succeed. This step in my day-to-day, this usually means talking to my project manager and kind of talking over a particular feature or bug fix that a customer has requested. And it's kind of my job to make sure that the feature that they want it's kind of my job to make it do the thing that they want it to do. And that means that I really have to understand where the customer's coming from. Like I really have to understand what they want. So there's a lot of back and forth between me and the project manager when it comes to understanding the problem. Now, if you don't have anyone to please, like a customer or whatever, and you're just working on your own projects, same principle applies. You've got to be able to explain in like one sentence, maybe two sentences, what you're trying to do. Because if you can't do that, then you're going to really struggle with with figuring out the rest of the problem. I don't know if any of you have read anything by Richard Feynman, but he's a hero of mine. He's a famous physicist that was kind of around, he kind of overlapped with Einstein back in the day. And he was one of the great teachers of science. Not only was he a great physicist and a great or a scientist, but he was a very inspiring teacher and professor. And one of the things that he said, I'm kind of paraphrasing, is that if you can't explain something simply, then you don't know it well enough. So this is something that I try to take to heart. If I don't understand the problem well enough, or if I can't explain the problem well enough, then I probably don't even understand it well enough. So this is pretty key. And, depending on what the problem is, understanding the problem could mean a whole bunch of different things. Usually for me, like I said, it's about understanding what the customer wants. And there isn't always like a design or something that I can base something off of. I kind of have to ask questions and be like, well, do they want a modal to pop up when this happens? Or do they want just a little toaster message to pop up? Do they want, oh, sorry, I've got to, here we go. I like that. If you can't explain it to a 6-year-old, you don't understand it yourself. Boom. Yeah, that's, I love that quote by Albert Einstein. And to answer Govani's question, LeetCode is really great. Edibit is just easier. Edibit has a lot more just simpler problems. So I think Edibit is really great for people just learning how to code. So that would be my answer to that, Govani. Yeah, so I definitely did Edibit more than LeetCode. To be honest with you, I didn't even know about LeetCode until well after I had graduated. And I to be honest, I didn't really use it that much. And it's not that I didn't like it or didn't think it was good or anything, because it's actually fantastic. I highly recommend LeetCode. I had just found other sites that I had just kind of gotten used to that I really enjoyed. Edibit I started with, and then I really liked Code Signal. It was like gamified, so that was really fun. And then currently I'm using, I'm not looking for a job right now, but I'm using following the book, what's it called? I'm working out of this book and now I can't remember what it's called. It'll come to me. Cracking the Code. Cracking the Code. It's got a lot of really cool stuff about data structures and algorithms that I really enjoy. So I've been working out of Cracking the Code, which has been pretty fun and difficult, but fun. So yeah, first step, understand the problem. Be able to explain it to a 6-year-old. Okay, the next thing is, once you kind of understand the problem, think about the problem in terms of what the context is. So that's what I mean by determine potential edge cases. So for example, let's say your test is, let me bring up an Edibit. So where's the one I was looking at? Here, okay. So for example, this puzzle, create a function that counts the integer's number of digits. Okay, well that seems pretty straightforward. But suppose what happens if you put in nothing? Suppose you don't pass an argument in. how should that be handled? Should it throw an error, or should it just output 0? These are important questions to ask. Suppose I put in not a number, NaN, right? Or suppose I put in something that literally is not the data type number. Like how should I handle these things? And depending on the situation, it's going to be different. And you know, when you're building something that people use every day, you generally want to code it in such a way that if something goes wrong, the user is given a reason why it went wrong, or at least a explanation of what went wrong. So in this case, it would probably make sense to throw an error that says, this is not a number, or you must provide an argument, or something that's informative, so that someone using this function or calling this function, if they pass in incorrect values or something that's invalid, they're instantly going to get feedback that says, no, you can't do that. So edge cases are really important. Another reason why your edge cases are important is because if you don't take them into account, you can get all sorts of weird, nefarious bugs that are not obvious. So any questions about that? Determining edge cases. All right. Next thing I do is I like to pseudocode the solution. This means I usually will I'll create files that I think I'll need, and then I'll just comment out the solution. I try to do it as succinctly as possible. Usually this just means like, okay, let's say, for example, on this function, integer digits count. I'm going to think to myself, okay, well, I need to somehow figure out how many digits there are in a number. Okay, well, I know that using the number data type, there's not really a way to know how many characters there are. You can't ask the number that. So, well, I guess that means I'm going to have to put it into a form where I can count the numbers. Well, a string or an array of the digits might work a little better. And then I can think to myself, okay, well, now I just need to ask it how many characters there are. So if I used an array or a string, which are pretty much our only options, I can use maybe the dot length property to ask how big it is. And we can use that to arrive at the answer. For more complicated problems, I try to break it down into as small bits as I can and pseudocode out each individual bit. And sometimes, I didn't really put this in here, but sometimes if the problem is really, really big or intractable, I try to break it down into a series of smaller problems. So, for example, I was working on a pretty complicated feature for an app that we're building at work. And one of the things that we had to do was create a drag and drop feature for dragging the rows of a grid into another grid. And there's all these rules for whether or not a given item that you're dragging could be dropped into a particular row. There were all these rules and things that would, and it needed to give you lots of different messages on, like, you know, you can drop here, but you can't drop here. Only certain types can drop here. And you had to let the user know about all this stuff. So it was kind of complicated, but the way to approach it, or the way that I approached it, was to be like, okay, well, the very first thing that needs to happen is to be able to drag and drop something. So I focused only on that first. And I pseudocoded that out into like, okay, a drag event starts at this location and a drop event happens at these locations. And then I got it to at least work in terms of, okay, I was able to drag from here to there. Okay, cool. And I'd get that all kind of set up. And then once that was there, then I could work on applying all the different logical rules for what could be dragged into what. And again, I just pseudocoded that out, figured out what all the edge cases were, figured out what all the different scenarios were. So I mapped them all out. Like I literally wrote them all out. There was like 20 combinations or something. But having that exhaustive list helps me just create a checklist basically. So breaking things down into a series of smaller problems is probably the most important part, besides understanding the problem. Any questions about that so far? Cool. All right, this one's pretty self-explanatory. Once you've kind of done all that preparation work, it's time to just get your hands dirty and just try to do it. You're going to, it's rarely the case that it's going to work the first time you do it. If it does, I usually doubt myself and rewrite it again anyways, because I'm like, there's no way that works the first time, because it never does. But one thing that I would recommend is when you're coding it, to use your debugger and if there's any other testing frameworks and stuff that you're using, use those things. I cannot emphasize that enough. You're going to save so much time by using the debugger as opposed to console logging everything. Console logs are kind of useful. I don't really have anything against console logging, but the debugger gives you a much more robust set of tools for seeing what your code's actually doing. Console log can be deceptive. The debugger is just a much stronger way of doing the same thing, in my opinion. So the next thing is coding's hard. It's really hard on your brain, takes a lot of energy, burns a lot of calories, believe it or not. And I highly recommend taking breaks. When you're crafting out your solution in the beginning, or breaking things down into smaller problems, take breaks after you've kind of accomplished a certain milestone. Be like, all right, I'm going to get to this point, and once I know that I can do this, go take a walk for 10 minutes. Walk around the building. Go get a glass of water. Like, do something, because you get diminishing returns the longer you stare at your code. And if you find yourself staring at your code for 25 minutes and you haven't written a single thing, that's usually a sign you're burned out. So taking breaks, I cannot emphasize how important this is, especially when you do this full time for a living. You got to be able to have the mental awareness and mental fortitude to admit when you need a break. So this is pretty important. Cool. Any questions so far before we go on to this last one, which I think is something that people don't tend to do as often as they probably should. But yeah, any questions so far? Oh, wait, my chat. Oh, where did my chat go? There it is. Okay, sorry, I'm not very good at getting to this chat. Here we go. All right. So to respond to John's comment, edge casing sounds like test-driven development. Yeah, there's definitely a element of that, for sure, where you kind of want to plan out ahead of time, like whether or not you wrote the test first, which is kind of the hallmark of test-driven development. Um, uh, whether or not you're doing, actual TDD, uh, edge casing is definitely something you want to do, where you're thinking about all the different ways that this particular functionality is going to get implemented. Um, and yes, test-driven development very much relies on planning out these edge cases, which is kind of the purpose of test-driven development, really, is to like explicitly say, all right, I expect these kinds of things to happen, or I expect or I expect this feature or functionality to be used in the following ways. So I'm going to prepare for them and test for them. So that's a good point. And to answer your question, yes, in fact, I don't have a whiteboard at home. I kind of wish I did. But I just have a handy little notepad that I write with a pencil. I'm kind of old school that way. I love the feeling of just, I don't know, graphite on paper. I tend to think through the problem a little more carefully when I'm writing it down. And it allows me to draw pictures. I'm a very visual person, so like I'll draw diagrams and um, I'll use like symbols and stuff. I kind of have my own like weird language for how I denote things on a piece of paper that's not really easy to do in an editor. So usually what I do is, especially when I'm just kind of brainstorming and I haven't even really gotten to when I'm still trying to either understand the problem or I'm still trying to figure out how to address the problem, or if I'm um, trying to come to my solution, uh, I'll use my notepad as much as I can. And then once I've gotten to that point, I'll comment things out I'll comment out the solution in pseudocode. But it just kind of depends on the situation. If the problem is simple, then I may skip diagramming it in my notepad. But yeah, that's a great question. All right, so it's really common, especially for junior developers, to once it works, they are just like, all right, mic drop, peace, and just kind of leave it at that. And unfortunately, when you do that, you tend to, it's usually not good enough that it just works. Yes, it's awesome when you get something to work. It's fantastic. It's a super satisfying feeling. But the key here, or something that a senior developer, senior engineer would do, is once they've got a solution working, the next step is to optimize it. And this can mean a lot of things. So the first thing that I look for when I'm reviewing on our team, we all review each other's code before it gets merged. And the first thing I look for is readability. So I don't care how many lines of code it is. In fact, the number of lines of code really has nothing to do with how good your code is. So if anyone tells you otherwise, then they're crazy. Now, yes, the longer your code is, the bigger your file size is. So, like, yes, it is true that you want to keep your code down to as few lines as possible. However, I would not do that at the expense of readability, because the thing is that you have to think about the development process as a whole. It's a whole process. And other humans are going to be using and reading your code. So your code should be readable. When you look at the code, it should be fairly obvious what it's doing. You may not understand the logic right away, and that's okay, but you want to write your code in a way that it's readable. Second of all, it needs to be testable. And we could do a whole series on just testability or testable code. But in general, you want to be able to test your solution in an automated way. And we're going to do that in a few minutes with just a couple little edit problems. Next thing you want to check for, or the next thing that's part of optimizing, is how efficient your code is. And next week, we're going to go into this. We're going to talk about big O notation, which is something that I think it's overlooked in boot camps, because it's definitely it's a much more technical aspect of coding, but it's incredibly important, even as web developers. We have to be aware of how efficient our code is. So this usually means after you've figured out your solution, go back over it and see, okay, how many loops am I doing? How efficient is this code? Like, am I making 50,000 calls to the API, and are those necessary? Like, is there a way that I can do it in half that many calls? Can I do this in fewer iterations or fewer loops potentially? How much memory is this code using? Can I do it using less memory? These are questions that you want to ask yourself, because it's great once you get it working, but you want to make sure that it's optimal. And finally, before we go into the code, one thing I didn't actually put here, which is also kind of important, is once you've got your solution, once you've optimized it, think about could you abstract this further? So what I mean by this is, let's say you have so for example, you've got this function and it adds two numbers together, and it's the most efficient function you've ever written in your life. It adds two numbers together so fast you wouldn't believe it. Well, we could abstract that even more potentially to say, okay, well, if this function can add two numbers, can we make it add any number of numbers together? So instead of just x plus y, what if we have x, y, and z? What if we don't know how many arguments there are? What if we don't know how many numbers may be needed to add up? Can we abstract our solution to kind of handle these other edge cases? So these are things you definitely want to be able to ask yourself. Is how much more abstraction is necessary? One thing I would recommend though is not getting too hung up on getting lost in abstraction hell. That's where you try to abstract everything away. Like, just solve the problem and then use only the amount of abstraction necessary to solve the problem. You'll save yourself a lot of headache and existential crises that way. But that's just my opinion. Cool. Are there any questions before we do some actual coding examples? All right. So I'm not sure that we'll get through all of these, but that's okay. I'll leave it to you guys to kind of do them yourself or work on them yourself. So, all right. I got 3 problems here. And we're gonna We're going to try to figure some of these out. So let me set this up so that we can at least test it. So these are just going to be functions that do the thing that it says. So our first example is we need to write a function that will add up all the integers from 1 to a number. Okay, so let's do this. We can call this function whatever we want. All right, takes an x, does something like that. Okay, cool. Let's put it into our test. So we'll import add up to x. Okay, from the outset, I have this function, or I'm going to write this function that takes a number and adds it to, excuse me, given a number, we want to add up all the numbers, all the integers from 1 to that number. So if we look at kind of our little list here, do any of you guys have some ideas for what edge cases we might want to handle before we worry about writing this code?
If x is negative?
Yeah, what happens if x is negative? What else?
Will there be a max?
Yeah, is there a max? What about we might be able to think of one or two more.
What about if they pass something that is not a number?
Yeah, okay. What if we pass in a non-number? One thing I can maybe think of is what if x is 0?
What if x is 1?
Yeah, what if x is 1? So yeah, these are all legit questions. So now this is kind of arbitrary. So we'll just kind of set our own ground rules for this. We'll assume that if it's a negative number, then we should throw an error. We'll just say arbitrarily that the maximum number is 100. We don't have to, but we'll say it's 100. And this one, now this one's interesting. What if we pass in a non-number? This one we probably want to throw an error. We could get fancy and try to, like, for example, if it's a string representation of a number, we could try to be like, okay, you can come in, we'll just coerce you to a number. But as I've done more and more and more work with TypeScript, these kinds of issues are actually very easy to avoid. So what we'll do is we'll just enforce that it has to be a number. We'll throw an error if it's not a number. It'll just be that simple. This isn't TypeScript, but I use TypeScript at my work, and it lets you handle these things very, very eloquently. Okay, and the last one, what if x is 0 or 1? Okay, so we'll just assume for our purposes that we'll just return 1. That's just our rule. We'll say if it's 0 or 1, we're just going to return 1. And if it's 2, it's going to need to be We're going to add 1 and then 2, so that should be 3. And if we do 3, then we should get 6. If it's 4, we should get 10, et cetera, et cetera, et cetera. So let's kind of handle some of these edge cases. So the first case is handle negative. So in my test, I'm going to expect that when I call add up to x with a negative number, that this throws an error. Okay, so we're going to say, okay, I expect if I call this function with the negative number to throw an error that says invalid input. No negative numbers. Okay, cool. So there's our error message. We'll go over to our demo and let's handle it. We'll say if x is less than 0, throw an error. And actually, no, I like doing actual errors calls. Okay, that's pretty simple. Let's see if it works. So I'm just going to run my test. Let's see what happens. It passed. Beautiful. All right. And we said that there's a max number of 100. So let's handle our max. In this case, I expect if I pass in a number that's greater than 100, so we'll do 1 and 1, we expect this to also throw an error. So if x is greater than 100, okay, we'll run that. This should pass. Beautiful. All right. Now we got to worry about what happens if we pass in a non-number. Alrighty. Okay, do this. Add up to x. We'll pass in string, which is nonsense. And again, this is pretty straightforward. Invalid input. Only numbers are allowed. And of course, we could test this with arrays, objects, whatever. But we're just going to test. We're just going to use that one case just for time's sake. Okay, now here's kind of a tricky part. Okay, well, does anyone know how we check whether something, how do we check that something is a number?
Type of.
Yeah, type of. So we're going to say if type of x is not equal to number, then we're going to throw an error. And we'll use that message that we wrote here. Okay, let's see what happens. Hopefully this works. Hey, it passed. And of course, we could put in like an array. That should also, basically, literally anything that doesn't register as a number will throw an error. But just for example's sake, boom, there it is, it passed. So it threw an error. Beautiful. Okay, now we can go here. Okay, what if x is 0 or 1? So in this case, we decided that, okay, if you pass in 0 or 1, then we're just going to return 1. So there's a bunch of different ways to do this. We could somehow incorporate it into the logic of the function. We could just do a simple if statement. Kind of a quick cheeky way of doing this is to say if x is less than 2, then return 1. This will suffice for us, I believe. Notice it's already checking for less than 0, so we've kind of got a cute little way of making sure that it's 0 or 1. So we'll just go here, and now we expect that when I add up x using 0, that should be 1, and if I pass in 1, that should be 1. Let's run that guy. Let's see if it works. Hey, nice, it works. Beautiful. Okay, now we've actually got to the fun part. Handle logic. Okay. Anyone want to volunteer a possible solution here? Anybody?
We can
Okay.
return n times n plus 1 divided by 2 by default. Then we can go from 1 to n. So it can be.
Sorry, say that again.
I said we can return n times n plus 1 divided by 2. So just mathematically. So we can go from 1 to n. So it can be O1 runtime.
Yep. Oh, and sorry, I didn't see some of the comments in here. Yes, there are some other edge cases here that obviously we could handle, such as decimals. We could use the is not a number method to check for things. Yeah, but for time's sake, we won't worry about that. This handles kind of most of our cases that we care about. But yes, we could handle this mathematically. And you said, what was it? N times n plus 1?
Yes, divided by 2.
Cool.
Put it.
Suppose though, let's say for those that are not mathematically inclined, what might be another way of doing it? In more of a rote way, what's another way we could do it? What could we use if we know that we need to go from some number to another number? What's something we have in our tool belt to use?
A loop?
Yeah, we could use a loop, where every loop we simply add to what we had before. We can start with our number, or we start from 1, and then we'll just add that number recursively, or not really, technically it's not recursively. But we just add that number to the next number, and then add that result to the next number, up until we get to our number x. There is obviously a more eloquent mathematical way of determining this, but just bear with me. So what we're going to do is we're going to say, all right, we're going to let our output, we're going to start with 1, because right, that's kind of what the problem determined from the beginning. We're going to start from 1 and go up to the number. Okay, and now we're going to say, okay, while our output is, we're going to ask the question, while our output is, we need our output, and then we're going to have our counter. So this is our iterator, the number that we're currently on. So sorry, so output's going to be 0, because we're just going to be adding to that. And then our counter, which is our, it's basically the, what's the word for this? The factor that we're adding every time. Or I should say the number that we're adding every time. So, actually, I guess that is 1, not 0. All right, so while the counter is less than or equal to X, right? Because we're counting from 1 up to that number, we're just going to simply add to the output. We're going to say, okay, set the output equal to whatever it was before plus the counter. And then we'll simply add 1 to the counter. And at the end of this process, we'll return the output. This is a very, very, very common pattern. The reason why I chose to do it this way is just to show, I just really wanted to demonstrate this particular pattern, this concept of you start with some value, you loop iteratively multiple times while updating the value in question, and then at the end of that process, spitting it out. This process happens all the time. It's just so common. So that's why I wanted to demonstrate this, do it this way. It's a little long-winded, I know. So let's test it. So we can use any numbers between 2 and 100, basically. So let's do one that we know offhand. So we'll add up to 2. And this should be 3. We hope this is 3. Oh no. We received 4. Oh, duh, that's because my output, that should have been 0. This is why having a debugger is really awesome. Hey, look, it passed. Okay, beautiful. So let's do another one. We'll do 3, which means that this should be 6. And then we'll do 4, which this should be 10. And they pass. Sweet. So after doing this, we can feel pretty good about our function. It's a lot better than just like writing it and then doing a few console logs and checking like, yeah, this is cool. We now have a very specific set of tests that we're putting it through so that we know exactly what it's capable of and what it's not capable of. So I'd say we've solved this solution pretty thoroughly. It's not perfect, but it's definitely pretty, it's pretty strong, I'd say. It's pretty robust. All right, so let me look at some of these questions. Honest question. How often have you or one of your coworkers done recursion for a typical problem at work? Let's see here. Technically, anything that you can do in a loop, you can do recursively. Recursion is just like we could do this problem recursively just as easily. Because they're identical, like they're logically identical. Recursion just has to do with the ability to call a function within itself, or sorry, call itself within its own function block. But to my knowledge, they're logically equivalent. Anything that you can do with recursion, you can do with recursion, or sorry, anything you can do with recursion, you can do with a loop, because they're the same. The only problem is that the call stack can potentially overflow. So you do have to be aware of how much space you're using up, because calling a function recursively does take up more space just by nature. So while they are logically equivalent, they are not necessarily space-time complexity equivalent. We'll talk about big O and efficiency next week, because I definitely would love to talk more about that. So we'll definitely get to talk about that next week, which I'm super excited about. But I'm looking at some of the comments here. So you guys are talking about time complexity of Fibonacci would be exponential. Can you explain what you mean? Because I don't think time complexity of Fibonacci is exponential. It's just linear.
The Fibonacci, when you use recursion, is you usually, the way people solve recursion with Fibonacci, you put Fibonacci and then the number -1 plus Fibonacci number -2, and then you're multiplying both. So if you do,
oh right, instead of like doing the subtraction first, and so you're saying that they call it twice within the function.
Yes, because that's a normal way to do Fibonacci. And even if you do cache, so you can cache that and don't call it twice, still, if the complexity, the time complexity is bad. So in the Fibonacci, because I solved the problem like 2 weeks ago, the best way is just to save the value in a variable and just to use a
right. Yeah, and you could do it recursively without making it. You could do it in the same with the same time complexity, not the same space complexity, but the same time complexity as just using a loop.
I don't visualize that. How?
That's a little bit out of the scope of the talk today, but I'll chat you.
Yeah, this one.
Okay, so does anybody have any questions about this? We got time to do one more problem, I think. Okay, cool. Let's go to the next one. So this one is fun. All right, so find the shortest word in a sentence. Okay. 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 Edge cases. I'm not going to be as thorough as the first one just for the sake of time, but anyone have any edge cases for this problem?
Empty. No.
Yeah,
empty
suppose
sentence.
an empty string, or perhaps a string that doesn't have any spaces in it. We'll assume that it's going to be a string. Okay, we'll for this we'll just assume that it's a string. We're not going to do any data checks or anything. We'll assume it's a string. There's one obvious one. What's that?
If the words are at the same length, two words of the same length.
Yeah. What happens if we have two words that are the same length? How should we handle that?
Error.
Make a decision.
You could, but there's possibly a better way of handling it than just an error.
You just, they're the same. If
They're
you
the
have two words
same.
of the same
So why
length,
not? So it's common to in tiebreakers like that to return just the first one.
yeah.
Could return an array with two or more.
You could do that too. You could also return all of all the ones that have or all the words with that length. That would actually probably be the best one. Is to return an array of all the ones that
I guess that goes back into the understand what the problem.
right. Yeah, that's a
asking
great
for.
point. Yeah, and in fact, I didn't even think of that when I wrote this. So yeah, let's do that. Let's if they're the same, then we'll return an array of the tiebreakers. And we'll change this up a little bit so that it will always return an array. If there aren't any ties, it'll still be an array, but it'll just have one item in it, which I think will work for our purposes. So yeah, we'll just return an array of tiebreakers. Cool. I think that'll cover it. So first case is, let's think of empty string. So I would argue that it's actually not really a problem. We should just return an empty string because technically that is the shortest word. So we'll just return an array with an empty string in it. So we'll just say, let's grab our function up here. Shortest word. And we'll say, I expect the shortest word given an empty string to be empty string. Okay. Oh. Equal. And like we said before, it's going to be an array of the solutions. So array of the shortest. So again, there's several different ways we could do this. So here's our output. If there's no word, or if it's an empty string, just push in an empty string. Then at the end, we'll return output. Okay, let's see if this works. And, I'll skip this test. Sweet, found it, beautiful. Okay, now let's say it's a word with no spaces. Okay, so now how might we do that? So what was this? How do we know whether something has spaces in it?
You could do a split or an index of or a couple other things.
Yeah, totally. Yeah, there's certainly a lot of ways we could do it. Let's do a split because there's a cute little way that we can know if it had any spaces, namely whether or not the resulting array only has one item in it. So what we'll do is we'll break up our oh, this should say sentence, not word. That's confusing. So we've got our sentence, and then we'll break it up into words. So our words are going to be sentence dot split, and we'll split on the spaces. Because what we know about the split function is if the character that you're trying to split by doesn't exist, then you basically just get an array with the original string in it. So now we can just say, okay, well, if words dot length is equal to 1, then we'll just return words. Okay, let's see if that works. This sentence has no spaces. Sweet. All right, let's see if this works. Sweet, still works, beautiful. All right, so now we can actually handle the fun logic, which is, okay, we need to somehow know the shortest words as we go. So there's a few ways to do this. And the fact that we're doing an array or outputting an array does complicate this a little bit, which I didn't really think about till now, but that's all right. So basically, in this case, what we want to do is think about how we arrive at knowing the shortest words. So there's a few different ways to do this. Now, regex would work. Actually, would regex work? I can't think of a way to do regex off the top of my head. I didn't really think about that. Because because I don't know if it would really be able to tell us anything about the count. Oh, I see. Yeah, that was the answer to know if you have spaces. Yep, regex would totally work for that. Yeah, that's what I love about coding. There's 1,000 different ways to do the same thing. Okay, so in this case, we kind of have to think about like, okay, well, we need to be able to not only keep track of the counts for each word, but also know what's the shortest one. So if we wanted to know just the shortest one, it's actually pretty simple. You loop through each word, you check its length, and you, how do I put it? You loop through each word, you check its length, you see if that length is shorter than the shortest one you found so far. And then at the end, whatever is the shortest is the one. In this case, though, it's a little harder because we need to actually keep track of potentially multiple strings for a given length. So we need to be able to like keep track of those. So what I'm going to do is I'm going to use an array to as a map where the index of the array is the length of the word. Okay, and at each index, it's going to point to an array of all the words that live at that spot. So it might, to visualize this, in the first index, we'd have an array of all the words that don't have any characters in it. That won't happen. That's always going to be blank because there's no such thing as a word with no character, or there's no such thing as a word with no characters in it, right? That's not, because we've already split it based on emptiness, so there's nothing to keep track of. But if we had the word hello world, or actually let's do the word I love you, we would have the word I there because I is in the I has one, and it match, or I has one letter in it, and it's at the first index. Okay, 2 would be empty. 3 would not be because the word you has 3 letters in it. And then the next one would have 4. If our sentence was I love you more, then we might have something that looks like this. And at the end, you just grab the array that has, you grab the array that exists at the lowest index in the map that actually has something in it.
That makes sense. I have a question.
Go ahead.
That more there, is that need to be in its own array, or should that be an
no.
element of the other? Okay.
No, that was my bad. You're right.
Yeah, that makes sense. That's a great one. Thanks for
Yeah.
that. That's a great
Yeah.
algorithm.
It's cool. And so like, basically you just go through all the way until boom. And this isn't, there's not really, I can't, off the top of my head, I can't really think of a much more efficient way of doing it than this. If I sat around and thought about it more, there might be some tricks you could do. But this would work.
Still want it to be readable.
Right. Yeah. So let's think about how we might dynamically generate a data structure that looks like that. So what I'm going to do is we know how many times we need to loop through, right? So we need to loop as many times as there are words in the sentence. So we could do a for each on our word or on our words array. We could also use just like a straight up for loop. Doesn't really matter. What we're gonna do here is, because here's what's tricky. We don't know what the words are ahead of time, right? Like we don't know what the lengths are of each word. That's like what we're trying to determine. And so we have to kind of dynamically add to this array as we go. So what we're gonna do is we're gonna check if the length of the word exists as an index of the map. Now, if not, we're going to create one and add the word. However, if there is, then we're just going to push the word onto the end of that array. So what that looks like, we're going to say if map at the index of the word length, right? Because we're using our array index to represent the length of a word. So if this length is 4, for example, then we're going to check the 4th index of our map and see if it exists. And one simple way to do that is to ask if it's undefined. If it's undefined, then we're going to say map word dot length equals array with the word in it. If it isn't undefined, then we're going to push into the array that already exists, our word. And then at the end, once we've looped through everything, we can now start from the beginning of the map array and just go until we find an index that has something in it that's not undefined. And then we know immediately that that is the answer, because the indexes represent lengths. Let me just put these comments in their sensible place. Okay, so then at the end, we're now going to say, okay, and all right, so we're going to start from the beginning of the map and go until we find an index that has something in it. We know that we don't need to start at 0 because there aren't going to be any words with a length of 0. It just doesn't make any sense. It's just not going to happen. So we're going to go until the map doesn't have a length. And we're just going to say if map at the place that we're at. So if map has an element at index I, that is the first, or that is the shortest set of words so far. Or not even just so far, just that's the shortest set right there. So if it's not undefined, there are other ways to check this, but I think this is the most explicit. If it's not undefined, then we're going to return map. It's actually All right, let's see if that works. We may have missed some logic. We're about to find out. So let's do something with just like 2 words in it. Something that's simple. So kind of a typical example would be expect shortest word. We'll do test 1. All right, what should we get? What do I expect from this?
1.
Yeah. Okay, cross your fingers. Hey, all right, well that's reassuring. All right, let's do another one. That's test 1, 2. So now 1 and 2. I expect that to be the right, or I expect it to give me those guys. Sweet, that worked. All right. Let's do test 1, 2, 3. I love coding. All right, what should this be? Should be pretty obvious.
Hi.
Yeah, it's just gonna be I. We hope. Beautiful. And one just last little thing is, let's just do, you could have a lot of fun with this and just kind of I expect this to be the same, or I expect, since these are all separated, I expect that to just be the same thing. They're all individual things. All individual words, technically.
Shouldn't they be each an element in the array? Each letter is their own
Oh,
element.
yes, thank you. You know what? I'm feeling lazy. I'm going to reduce this to only 5, so I don't have to write so many letters. Yep, thank you for catching that. All righty, let's see if that works. Boom. All right, I think we can be pretty happy with that. There's certainly some optimizations we could probably make. I'm not sure off the top of my head if this is the most efficient way of doing it, to be honest with you. Because it's not quite O(n) time. And if you're not sure what big O is, we're gonna talk about that next week. But yeah, this is not quite linear. It's a little worse than linear.
It feels like 2n.
It's not quite 2n. In the absolute worst case scenario, yeah, actually no, you're right. In the worst case scenario, it's 2n. Yep. Because in the worst case scenario, our shortest word could be at the very, very end of the map, and also the very, very end of the sentence. So
Yeah, because that map isn't free.
Say what?
Because map is not free. Map has computational time as well.
Yep, exactly. Because you have to loop through map as well as the word. So there's 2 loops. Now, on average, you're not going to be looping through map like you're not going to be looping through the entire array, especially if, a short word is early in the sentence. But that's not guaranteed. And you measure your efficiency by the worst possible scenario. So this would be 2n. And for those of you who have no idea what I'm talking about, that's okay. We're going to talk about this next week. But anyways, so to kind of just recap, understand the problem, figure out your potential edge cases in the beginning, pseudocode it out, diagram it, whatever you need to do to kind of get a handle on your solution. Break it down into individual parts that are easier to tackle individually. Code the damn thing. Use your debugger to try to fix things when they're not happening the way that you think they should or shouldn't. Take breaks. I'm about to take a break because we're almost done. And then afterwards, optimize your solution. Check for readability, testability, efficiency, the size of your files, etc. Is more abstraction possible necessary? In this case, you could, of course, abstract this into something like whether something is a word. Is this a word? Is the letter B technically a word? You could maybe make it so that there are certain rules that you apply to whether to count whether something is a word or not. Perhaps you want to be able to count things like this, which is the new line tag. That would kind of fit more into the edge cases scenario. Perhaps these need to be parsed better. What if this is an HTML element or something, or an HTML string? These are things you might want to think about. But anyways, I hope that was helpful for you. So as homework, we didn't quite get to this one, but if you guys want to try to solve this problem, this is one I kind of made up. Produce a graph which represents the count of each character in a given string. So that just means that if you have a string, let's say hello world, your output is going to be an object that maps the characters that exist. So in this case, I won't do this in alphabetical order. An object would do this, but this would say 1 because there's one H. E, there's one E. L, there are 3 L's, etc. I hope you get the idea. Try to make a function that produces an object or a map, a graph, whatever you want to call it. They're all kind of the same thing.
So not including the letters that aren't in the sentence, like you wouldn't have like A0.
No, but that's a great, you're thinking about this in the right way. Maybe you do. Maybe you do want to account for that. Maybe you have a specific character set that you care about. For example, maybe you want to have your function specify what encoding to use or what alphabet to use. What counts as a valid letter. These are all things that would be really great and taken into account. And I can say from my own experience, when I had to write an app that had to cater to any language, therefore Chinese, Japanese, Korean, whatever, Spanish, I had to be able to account for these kinds of characters. So that is a great point. Maybe you do want to know what the count is for a given alphabet. But as a bare minimum, you can just worry about, for the sake of this, to start with, is just worry about the letters that exist in the string itself. But
And do you differentiate between capital and lowercase?
for this challenge, yes. But if you want, you can decide not to. But for this challenge, yes, I would say, for the sake of solving the problem, yeah, it would be because a capital E and a lowercase e are technically different characters. So I would say yes. But I don't have time to go over that right now. But for those of you who want to give it a shot, good luck. And does anybody have any questions before we?
There's a request to see
Call
what
it
your
day.
package.json looks like.
Say what?
So there's a request to open up your package.json to see the jest.
Oh,
arguments.
yeah, sure. Yeah, sorry, I keep forgetting to check the comments. Yeah, it's just jest. That's the only one I'm using. I try to make this as bare bones as possible.
And you could have put jest inside your test value on 7, right?
Yeah, and the reason why I didn't is because I'm just using the built-in jest debugger in Node or in VS Code. But yeah, you could just as easily do this. Oh, yeah, this is bad syntax. That's gonna break. But yeah, that's all I'm doing. Any other questions? I'm not sure who is still left at the end. Nice, we still got a good crew. But yeah, okay, cool. It passed. Word. Well, that's all I got today for you. I hope that was helpful.
That's awesome. Thanks, Ben.
Yeah, no problem. I guess I'll hopefully see you guys next week. We'll talk more about Big O. So that's pretty cool.
Thank you.
Yep, you're welcome. Have a good one.